29. Luisa has a salad fork and a dinner fork. So here are the two forks. Use a ruler, got one here. Measure the length of each fork to the nearest centimeter. Okay, not too tough so far. I do have to make sure when I measure that I am using the centimeter side of my ruler. So there's 13 centimeters right there. Need to measure the longer fork. Now here I run into a little bit of a problem. See, my ruler is not a full-size ruler, so it doesn't go all the way to 12 inches like it normally does. So I can see that I can't measure the whole thing, but what I can do is this. I know that this is where my ruler stops. I'm going to put a mark here. I know from here to here is 15. Now that I have my mark there, I'm going to line my ruler up here and I can see, oh, okay, so it was 15 and then one more centimeter. Then all I do is add up my numbers. 15 plus 1 means 16. 16 centimeters. Now, if you have a ruler, because again, I know mine's like a mini ruler. If you have a ruler like a regular size one, you wouldn't even have had to do that. You could have just measured it all at once. Which measurement is closest to the difference in centimeters between the lengths of the two forks? Whenever they say difference, or whenever they ask you for a difference on a math test, they are asking you to subtract. So when they say they want a difference between the two forks, that means they want you to subtract 16 and 13. 16 minus 13. 6 minus 3 is 3. 1 minus 1 is 0. So my answer is 3. 3 centimeters. I look at my answer choices. That means answer choice D was the correct one to pick.
Okay, thank you.
Don't forget, for symmetry, it's all about ending up with two equal parts. That's all symmetry is. So for you to take it, like, let's say my sticky note here. If this is my shape, symmetry means that I can take my shape and I can fold it. Let me fold this side. I can fold it. When I do, I end up with two equal sides. See how there's nothing sticking out? Everything's the same. There's not a big side and a small side. They're both equal. You see how I have that line here now? That's my line of symmetry. Now some shapes, like this square, have more than one line of symmetry. This is not the only way I could fold my square and still have two equal parts. I could also fold my square like this. And I'd have two equal parts. One side is not bigger than the other. I don't have any parts like sticking out. They're both lined up perfectly with each other. And I have a new line of symmetry. So now I've got two. I could even do other ones. Since this is a square, squares are really good for symmetry. I could fold it this way. You see how, again, I don't have any parts sticking out? They're both the same. If I unfold it, I've got a new line. There's even one more I could do. Go this way. Fold it again. And look again. Two equal sides. Nothing sticking out. Both sides are the same. I have another line of symmetry. So symmetry means that if I were to fold the shape or cut the shape, where my scissors went, but if I were to cut this, I would have two equal parts. This question said they wanted me to find a shape that had two lines of symmetry, exactly two. So it couldn't be a shape that only had one line of symmetry. Couldn't be a shape that had 3 or 5 or 10. Couldn't be a shape that had 0. Had to be 2. Answer choice A only has one line of symmetry. This line right here. If I took this shape and I folded it, I could only fold it one way that would give me two equal sides. If I try to fold it any other way but this, I wouldn't have equal sides. One side would be bigger or one side would be smaller. So it only has one line of symmetry. For answer choice C, this shape has more than two lines of symmetry. This shape had 5. There are 5 different ways I could fold this shape and still have equal sides. Just like with our square here. Like I said, some shapes are really good for symmetry. They have a lot of different ways you could fold them and have equal sides. Another one like that is a circle. A circle is great for symmetry. It has so many different ways you could fold it and still have equal sides. This pentagon is similar to that. Kaylee, second time. Put it away, please. Answer choice D looks like it could have a line of symmetry, but what messes it up are these little parts that stick out here. If you look at them really closely, I can see that they aren't lined up. They're not on the same spot. Also, I can see it again if I look closely. They're a different shape. See how one of these sides, see how it's got a right angle there? My sticky note fits perfectly. Look at the other side. You see how it's got a different angle now? So if I tried to fold this shape over, I'd have a part that sticks out. It wouldn't match up perfectly. If I have a part that's sticking out, like this would be here, that's not symmetry, because those two parts aren't equal. So that's what you're doing when you're looking for symmetry. You have to look for places that you can fold or that you can cut those shapes and end up with two equal parts. Now answer choice B had exactly what they're looking for. It had 2 ways that I could fold or cut the shape and end up with 2 equal parts. I could make my fold here, and if I folded my shape over like this, I'd have 2 equal parts. Or I could make my fold horizontally. If I did that, hold on, sorry. If I did it like that, I'd have 2 equal parts. So this one had exactly what they were looking for. 2 different ways that if I could fold it or cut it, it would be equal. So do you understand now, Jaylene? Yeah? Okay. Melanie paid $37.56 for a pair of tennis shoes. The digit 5 in this number has a value of blank. Remember, whenever they write a number for you, whenever they write the number in word form, if you see the word and, they're telling you there is a decimal. Wherever you see the and, that's where the decimal goes. So whenever I see the word and in a word form number, I just turn it into one big decimal. I know this number is going to have a decimal. I know it, I know it, I know it. I know that in front of the decimal it says $37. Two place values here. I know behind the decimal it says 56 cents. Now I need to put what place values everything is in. I know that the ones place always goes in front of the decimal. It's right next to it. They're like best friends. In front of the ones is the tens place. Now behind the decimal, right behind the decimal, I have the tenth place. Again, it's got that th at the end, kind of snake sounding end. Tenth. I know the tenths, if I'm talking about money, are like my dimes. And I know that if I was going to write them as a decimal, it would be 0.1. After the tenth, I have the hundredth. And again, it's got that ending, hundredth. I know if we're talking about money, the hundredth are like my pennies. And I know if I were going to write them as a decimal, it would be 0.01. They're asking about the digit 5. So they don't care about the 3, about the 7, or about the 6. They only care about the 5. The 5 is in my 10th place, in the dimes, 0.1. I look at my answer choices. A says 5 times 1. 5 is not in the ones place, so it can't be that. Answer choice B says 5 times 10. It's not in the tens place either, so I can't pick that. C says 5 times 0.01. That's close, but 0.01 is the hundredth. And the 5 is not in the hundredth place. So I can't pick that. D says 5 times 0.1 dollar. 0.1 matches exactly. My answer is D. See now, Christopher? I can check, but if you put that answer, you didn't get it wrong. Nope, you didn't get it wrong, Christopher. Yeah, you put answer choice D, but you got it right. You didn't miss it. Let's see. No, that wasn't on the list I told your grandma, Christopher. Unless you're thinking of a different problem. Could have been. Data number 11. Let's take a look at number 11 then. Remember, like last time, Christopher, I told you to take the test home with you over the weekend. That way you got plenty of time to look at it. This is why. If you wait till Monday, there's a lot of time for you to forget different things, and then we start getting confused about which problems we need to work on and which ones we don't. You can't just keep leaving your work at school. You need to make sure that you're taking it with you if you need to be working on it. Okay? Number 11. Okay. Number 11 is kind of a tricky one, Jada. The fraction 3/4 can be represented by the expression 1/4 plus 1/4 plus blank equals 3/4. Which fraction belongs in the blank to complete the expression? So they're telling you this is what they want. 3 out of 4. 3/4. So far they've got some parts. 1 out of 4 plus 1 out of 4. So they have that. Let's see if they have that already. 1 out of 4 plus 1 out of 4. That's what they have. They're missing one last part to make 3 out of 4. And they're asking us, well, what's the part that we're missing? First thing I would tell you, it's like I've told you before, your denominator is the most important number in your fraction. Look at all my denominators. 4, 4, 4. So my denominator better stay 4. I'm going to get rid of any answer choice that does not say 4 as a denominator. Got 2 answer choices left. Okay. B says 1/4. D says 3/4. If I add one more fourth, it'll match, won't it? Now these two are the same. If I try to add 3/4, that means it would end up looking 2, 3, like this. And that looks very different from what I want. So my answer was 1/4. If it's still confusing to you, that's fine. There is more work that we're going to be doing with fractions in the next few weeks. So we'll get more practice with these ones. So if it's still a little bit confusing, don't worry too much about it. Okay? But that's how we find the answer for that one.